Okay, in this video, I'm going to show you how to host the Jupyter Notebook servers in the SOSCIP project. So we're going to not only host one Jupyter Notebooks, but two Jupyter Notebooks today. So I'm going to show you how to use the login node with only one external IP address that you can host two Jupyter Notebook servers on SOSCIP Cloud. So assuming you have multiple users and each of them has their own virtual machine. And my example here shows we have two members in the team. We have Jupyter's VM1 and the Jupyter VM2. Because SOSCIP project has only one external IP address, so we will have to create a login node and attach this external, or people call it floating IP, to this login node. Inside this login node, I already set up port forwarding. So when I SSH to a certain port of this IP address, it actually redirects me to one of the virtual machine. So I'm not going to talk in details about how to create a login node and do the port forwarding. If you don't know how to do it, you can go to this documentation, configuration, and port forwarding. So this document will show you how to do port forwarding, and including how you set up this firewall rule inside the VM, and also do the firewall rule, also known as security group rules, outside the VM on the cloud OpenStack level. So I'm not going through all the details, but I'm going to show you the port forwarding I'm doing here. So you can check the security group of the login node, and then you see I have the default security group, which is only for the SSH, that is port 22. I also have the RDP, so which opens 3389, and I also have my customized port forwarding script, so I can show you what's inside. So here I open other ports other than the default 22 and the RDP 3389. I have 2221, that is the SSH port to virtual machine 1, and 2222 is the SSH port to virtual machine 2. 3389.1, that is for virtual machine 1, and that's another RDP for virtual machine 2. Okay, so let's move on and to set up a Jupyter Notebook in one of the virtual machine. So I'm using a GPU virtual machine that is based on an IBM Power 8 server, so which has P100 GPU, so this flavor. So you can create your instance using this flavor, and this is an empty image, so I don't have anything like any Python Anaconda installed or any machine learning software installed. So I'm going to show you step by step today how you can configure a Jupyter Notebook and connect to your Jupyter Notebook through this login node. Okay, so the first thing we need to do on this machine is to create a normal Linux user. So when you create this virtual machine, you create a root account, but it's not suggested to use root to run a Jupyter server because you don't want to risk any security issues, right? So if someone hack into your Jupyter server and it got root privilege, that would be very dangerous to the system. So I suggest everyone to create a normal user and use that normal user to install the Python softwares and create a Jupyter Notebook servers and even host your data. So only if you need to change the system configuration or doing some system upgrading, then you use your root. So other than that, just use your normal user account. Okay, so I'm going to log in as root and create a normal or regular user. So it's very easy. You can just go to here and search user, and it will direct you to this place. And you can add a user, and you call the name, whatever. You call it user, or you call it Jupyter user, and you set up a password for it. And now, so there will be a Jupyter user that we need to use it for installing softwares. Okay, so let's switch back. Okay, so as I mentioned, I set up a port forwarding on this login node, so I can just do SSH or doing RDP. So in this case, I'm going to show you the example using the RDP to log into to this Jupyter server virtual machine. So I'm running the Mac, so I can download a Microsoft Remote Desktop app from the Mac's App Store. So if you're using Windows, you don't need to download anything. You can just search remote desktop connect or remote desktop client. Just search something, and it will show you. If you don't find anything on your Windows, maybe some version of Windows that doesn't have this software installed by default, but you can go to Microsoft Store and search remote desktop, and you can get that software installed for free. Okay, so let me switch to this Microsoft remote desktop page. So when you log into this computer, you are not using this IP address. You are using this IP address also with the port. So you can create a. Let me just do it. So 89.2. And let's just switch to this. Okay, so you just connect to connect to an IP address like this. So you put the port number that I set for this particular virtual machine. This is Jupyter Server Virtual Machine 2, so it's 3389.2, and we can set up some configurations, and I can log in as root, or you can log in as the normal user you just set. So I'm using root as an example here. having some troubles here, so maybe I'll just use SSH. Let me try again. Oh, okay. I can log into the Jupyter users. It's the same. Maybe I just tapped the wrong password. Okay, so let me share the screen with you. Okay, so you can see the title here. It's actually to a particular port. It is the IP address is associated to the login node, but if you add this port, we are actually going to the GPU node. So we can verify. But let's just do a NVIDIA SMI. So you see this is a different virtual machine. Okay, so we are logging as the Jupyter user. So what we should do today is to download the Anaconda first. So let's just do Anaconda. When you download the Anaconda, you have to be aware that the version you download must match the system architecture. So we're running Linux, of course, but this particular virtual machine is an IBM machine. So we have to download the Anaconda Anaconda version that's running on the IBM system. So in this case, we have to download this PPC 64LE version instead of the regular Linux version. Okay, so just get it download. And let's just install this first. We can just do bash, accept this, and pick up a location. So this is the default home location. It's fine. Yeah, so once the Anaconda or Anaconda is installed, we can use that to install packages like PyTorch or TensorFlow. Okay, so yeah, so if you create a new terminal, then you will see Conda environment is activated. So base Conda environment has very little thing. We need to install software. Instead of installing directly into this base environment, I highly suggest you to create a separate environment because the versions are different. You're downloading this Python 3.9, but many machine learning software that built for IBM machine doesn't support Python 3.9. So it's only 3.8 or 3.7. So I suggest you to create a separate Conda environment. It's very easy. You can do Conda create, let's say Jupyter, and put some software. Maybe we do Python 3.8. We'll do PyTorch, and do notebook, and maybe do something else like SciPy, Pandas. It's really up to you. So you can, as long as it's supported on this IBM machine, and you should be able to just install. So let's say how it goes. So it tells me it cannot find PyTorch. Why? Because Anaconda channel, if you say here, so this is the default Anaconda channel. So Anaconda channel doesn't provide a PyTorch built for IBM hardware. So in order to get a PyTorch built for IBM hardware, you need to specify another channel of Conda. So IBM now provide a repository called OpenCE. So it's like a building scripts for those machine learning packages. So there are public available Conda channels. I'm using one as example, that's the one from MIT. We do have a repository internally for SOSCIP, but as example, I'm using the public available. So it's called opencv.mit.edu. So every time, remember, every time you install a package for machine learning, that is, you want to install it on this IBM Power system, you have to specify this content channel. Otherwise, it won't find the machine learning package that you want. Yeah, so this time you see they find a PyTorch somewhere here. Show you. So this is a PyTorch that is actually from the OpenCV channel from MIT. Okay, so let's give it some time. So by default, Jupyter Notebook, when you start a Jupyter Notebook server, it only allows you to connect from local computer, which means that you can only use this web browser on this VM. If you want to use your own web browser on your own machine to connect it, it won't allow you to do it. Because by default, it's just set in this way. So there are some extra works you need to do in order to make your Jupyter server available to the public. So there is official documentation that we will use today. So you can search Jupyter Notebook server, and the first one is running the Jupyter Notebook server. So there are multiple steps that you need to do. So first, the thing is to generate a notebook configuration file. So let's do it. Switch back to, yeah, it will take some time. So I'll just go through the basic steps. So we need to generate this. We need to set up a password. We need to generate the SSL key. We can do self-signed. If you have some like a public signed certification, you can use it. But for personal usage, we're not hosting any website, so we can just use this self-signed certificate. And then all you need to do is to set up this configuration file. It's something like this. Just put this self-signed certificate here, and then put the password hashed password here, and set up a port. And then when we start the Jupyter Notebook, it will allow you to accept a connection from the public internet. Okay, those are basic steps. So let's see if we have everything installed now. So it's still installing. Okay. So remember that all the software we are installing right now is actually inside a separate content environment. So we have to activate the content environment every time we want to run anything. So we have to make sure that this is active. We can verify just to import torch. We can do torch CUDA. Yeah, it will show you the GPU is available. Okay, so let's do one by one. First, to generate the config file, generate a password. Let's do this. Okay, then we copy this somewhere here, and then we can log out. The next step is to generate the self-signed certificate. Okay, so just copy this command. Yeah, you don't have to fill all the information. It's okay. It's a self-signed, so your web browser will give you a warning anyway. And, okay, so we have this, and maybe we should put them to the home folder. So let's go back. So it's on the home folder. So let's get the absolute path. So use the pwd command to get the absolute path, and we can modify this config file. We can copy and modify this example here. Okay, so let's modify. This one is from home Jupyter user. This is also from home Jupyter user. And we need to put the password hash. Okay, so you can change to a different port, doesn't matter. So, but we have to remember this port is 9999. Okay, so then we can start a Jupyter Notebook. And we can put it into the background, so if you want. So just put this to background. And we can verify locally first. So let's go to this web browser and let's do HTTPS localhost 9999. Well, it will send you a warning anyway. Like I said, it's a self-assigned certificate, so you have to do. Yeah, so here is the Jupyter Notebook server. Let's see if we can log in. And because when we launched this Jupyter Notebook, we launched it inside this Conda environment. We have to do this so we can have all the packages we've installed. If we launch the Jupyter Notebook outside, then you won't be able to see your packages. So make sure when you launch the Jupyter Notebook server, you actually have an active Conda environment. So let's try it. Just do a notebook, and let's try a torch example. Let's run. Okay, so it's actually running. All right, so this only means that the Jupyter server is running. It doesn't mean that you can access this server from the internet. So remember we have a login node that we can do port forwarding. So the idea behind is when you are on your local computer, you access the login node IP address, but with a special port that defined by you, and that special port will redirect your traffic to this particular VM that we created on the port 9999. So I'll show you how to do. So we can log out this. Okay, let me just switch to another one. Log into the I'll log into the login node this time. Okay, so let me switch the screen. Okay, so this time you see the IP address exactly the same, but without the special port number. So this is actually the login node we have. And I already configured the port forwarding. So just something you have to make sure that the system control, just check the status of firewall daemon. It's active, and you can open the firewall config. And we can see, okay, so the zoom, we go to trusted zoom, and then we go to the port forwarding. So here you see the port forwarding I already done here. I forward the port 3389.1 from the login node on the login node to a remote port 3389 on the virtual machine. So here we need to add another firewall rule to forward the port, maybe 8081, so that's on the login node, to another port. So remember the local IP address. Let me check. So the local IP address is this. I have to copy and paste it here. So I'll just type it 172. 172. Okay, so it's just slow internet connection. So this IP address is the virtual machine that has a GPU, and we just configured Jupyter Notebook on it. And remember the port is 9999. Okay, so now we have another port forwarding rule. And let's save it to permanent. And let's switch back. Okay, so this is the IP address. So what if we do this plus 8081? So what happened? So you see, we're not able to connect because we haven't opened the port at the OpenStack level. So like I said, the security group. So we have to edit the security group to open this port so people outside can access. So let's just manage this rule and just add one 8081. So that direction must be an ingress. So it's incoming traffic. Okay, so then we do it again. So you see they give you warning because we are self-assigned. So we have to allow this. Here we go. So we have the Jupyter Notebook and we can log in. And we can run this kernel to verify if we are on the GPU server or not. Yes, so, and yeah, so you can do the same thing for other VM of yours, and you can have as many VM as you want, as long as you are under your quota. So see, we have another VM here, so we can do another configuration. So we need to configure port forwarding and open the port. Okay, so this is everything for today. And if you have any questions, if you need any help, just go to this ticketing system just to create a new help request, and we will be there to help you. Thank you.